This video is brought to you by mywayteaching.com.
Next concept is atomic mass. What do you mean by atomic mass? Atomic mass. Atoms of every element have their own definite characteristic mass. It is called as atomic mass. Means atoms of every element. In one element which consists of atoms, they have their definite characteristics of mass atoms. So this is called atomic mass. Okay. So here the atomic mass or the mass of an atom is actually very small because atoms are extremely small. So mass is why consider here mass of an atom is actually why it is very small. Okay, mass is very small because atoms are extremely small because atoms are extremely small. Okay, so example hydrogen. So before going to that, today we have sophisticated techniques. Example mass spectrometry for determining the atomic masses fairly accurately. Okay, so for determining of now we are using mass spectrometry. Mass spectrometry now we are using for determining the why we are using it, determining the mass. Okay, mass of the atoms masses accurately. But in 19th century scientists could determine mass of one atom. They determines only one atom relative to another by experimental. Okay, so means as has been mentioned earlier, so how they are calculating the mass of the other element, just they will consider only one mass, they will find out only one mass of atom by using that element. Okay, by using that they are finding the other mass of the element. Okay, so example for this, I will erase it first. So the important one I will explain now. So first one, just consider the hydrogen. Okay, so which is being a lightest atom was arbitrarily assigned a mass of 1. Hydrogen mass is 1. Okay, without any units, and the other elements were assigned masses related to it other. So this is just this is like a reference we are using. um, Related to this we are measuring other elements. Okay, so however the present this is in earlier system. This is now we are using um, atomic masses is based on carbon. Okay, carbon 12 we are using, so as the standard, and has been agreed upon 1971 19 sorry 1961. Here carbon 12 is one of the isotopes of carbon and can be this is carbon 12 is one of the isotopes of carbon are what, C12, C13 and C14. In that, so this is one of the isotope of the carbon. So how it can be represented, isotope of the carbon is represented like 12C, like this. So in this system 12C is assigned a mass of exactly 12 atomic mass unit. So the 12 atomic mass unit, AMU. Okay, this is called as AMU, 12 atomic mass unit. And masses of all the other atoms are given relative to this standard. All other, this is the nowadays we are considering this is 12 atomic mass unit. Okay, relative to all other atoms are given so that they are relative to this standard. So one atomic mass unit is defined as a mass exactly equal to 1/12 the mass of one carbon 12 atom. So Okay, the mass of 112 carbon atom. uh, so please note it down. In earlier system we are using this hydrogen, okay, which is having the mass 1, so we are using this as a reference to find out the other elements. Now we are using carbon 12. Okay, please note it down now what we are using and all. And the next one is in that only. So how the 1 AMU is defined as AMU. AMU means atomic mass unit. Okay, so which is equal to the 1/12 the mass of one carbon atom. Okay, 1/12 the mass of carbon 12 atom. Okay, so this is about 1 AMU. 1 AMU 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. Okay, like mass of an hydrogen atom is mass of hydrogen atom is 1.6736 into 10 raised to minus 24 gram. So in terms of AMU, if you want to calculate it means just you consider this 1.6736 into 10 raised to minus 24 divided by 1.66056 into 10 raised to minus 24. So how much you are getting for this? 1.0078 AMU. So just you can this can be written as 80. Okay, so that 1.0080 AMU. Similarly the mass of oxygen is 16. Okay, atom would be 15.995 AMU. Today AMU, this has been replaced by only U. Okay, so which is known as unified mass. Nowadays which is known as unified mass. Okay, which is known as unified mass. See, which is known as unified mass. Now it is called as unified mass. So this is about atomic mass. Atomic mass, this is about atomic. Please, here you first have to tell the definition. Okay, so in earlier system what we are using, hydrogen, mass of hydrogen is 1. Nowadays we are using 12 carbon 12 isotope as a reference. By using this we are calculating AMU. So now AMU is defined as U. So the whole summary of this atomic mass is this. Okay, please note it down. This is important so that whatever if they are asking about atomic mass you can explain all this. Next concept is average atomic mass. Okay, so in average atomic mass, many naturally occurring elements exist as more than one isotope. Okay, like a carbon which is having isotope carbon 12, 13 and carbon 14, correct. When we take into account the existence of these isotopes and their relative abundance is percentage of occurrence, the average atomic mass of that element can be computed. Okay, average atomic mass, how we are calculating means, so consider the example for isotopes of carbon. Now consider the example for isotopes of carbon. So this is isotopes of carbon. Next, relative abundance. Okay, then the atomic mass, which is atomic mass is AMU. Okay, In that, in isotopes, consider carbon 12, carbon 13 and carbon 14. Relative, this is 98.892. This is 1.108. 2 into 10 raised to minus 10. Okay, then the atomic mass here 12 carbon, and this for this 13.00335. Okay, and this one 14.00317. Okay, now you by just considering the isotopes, relative abundance and atomic mass, you can calculate the average atomic number. From the above data, the average atomic mass of the carbon will be calculated as just three isotopes with relative abundances and masses. Okay, so just consider this. Okay, 98.892 into 12. Okay, this can be written as 0.98892 into 12u. Okay, plus the consider now this 0.01011 not this one, into this 13.00335 u. Next, plus 2 into 10 raised to minus 12. Now, why this is 2 into minus 10 raised to minus 12 here, which is 2 into 10 raised to minus 12. Okay, into 14.00317 u. Next, final answer is 12.001 u. Okay, similarly, average atomic masses for the other elements can be calculated. In the periodic table of elements, the atomic masses mentioned, okay, the atomic masses mentioned for different elements actually represented their average atomic masses. Atomic masses is they represents average atomic masses, like that. So these are the isotopes of the carbon. I will explain it to you again. These are the isotopes of the carbon. Okay, so these are the relative abundances and this is the atomic mass. Just by multiplying these two, and adding all these, so you are getting the atomic mass. Okay, this is about average atomic mass. Next, coming to the molecular mass. Okay, next is molecular mass. Molecular mass is the sum of the atomic masses of the elements present in a molecule. Okay, it is the sum of the atomic masses of the elements. Masses of the elements present in a molecule. So this is about the molecular mass. Okay, before going to this, just consider the example, then you will understand this definition. It is a mass, it is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. For example, molecular mass of methane, which contains molecular mass of methane. How methane can be represented as CH4. Okay, here, which consists of only one carbon atom and four hydrogen atoms. Okay, so the molecular mass can be calculated as carbon, which is having the for the carbon only one atom, mass of the carbon 12.011 u, plus this 4, it is 4 hydrogen atoms, hydrogen mass is 1.008 u. So by adding that, you are getting 16.043 u. So like carbon, mass of the carbon is this, atomic mass of carbon, and atomic mass of the hydrogen is this, which is having 4 atoms. Okay, Similarly, so this is about the molecular mass. Similarly, if you want to calculate for water, second one example, so you just consider 2 into atomic mass of hydrogen, okay, atomic mass of hydrogen plus 1 into atomic mass of oxygen. So 2 into atomic mass of hydrogen is 1.00 8u, you just remember it, okay. So into 1 carbon is 16.00 u, so you will get the answer of 18.02 u. So here just consider 2, the number of hydrogen atoms is 2, it is multiplied by atomic mass of the hydrogen like atomic mass of oxygen. So this is one example, methane, and the second one example is this, okay. The first example is methane and the second one is water. So this is about the molecular mass. Some of the atomic masses of the elements present in a molecule. Atomic masses of element, okay. How many atoms are present? So just adding it, so you will get the answer like this. This is about the molecular mass.